Okay, so hopefully you've already watched the first video that gives the introduction to implicit differentiation, so you know the basic idea. So now, assuming that you've already watched that video, let's just jump in and we're going to be doing some examples of working with it. So this one, there are two different products for each thing. There's a product here, there's a product there, because you have two different things multiplied together. Whenever you have something like that happening with two different things multiplied together, you have to use the product rule. So in this case, we're actually going to apply the product rule twice. Okay, so for this one, we're going to do product rule. So we're going to do first thing, that's your f, and then your y is going to be your g. So first times derivative of the second. Whenever you have a y by itself and you want to do a derivative with respect to x, that's going to automatically turn into dy dx. So first thing times derivative of the second plus the second thing y, the derivative of the first, we're going to apply the product rule to the x. So again, whenever you get to the point in the problem where you're trying to find the derivative of x, that's always going to be a normal derivative. You're not going to have anything else that comes after it. 2 comes down, 2x, that's going to be it. Okay. So that takes care of the derivative of the first term when you multiply those together. So we have plus this next term. So now we have to do another product rule for this one because that's another product. Alright, so the f is y squared, so we got the first thing, y squared, times the derivative of the second, derivative of x is 1, plus the second thing, x, times the derivative of the first. Now, when we do the derivative of the first, that's going to involve the chain rule. That's that implicit part I mentioned before in the previous video. You do the outside power, you're going to bring the 2 down, subtract 1 from the exponent, but then you need to multiply by the derivative of the inside because again we're doing chain here. That's dy dx. Okay, so again, don't forget about that chain. You do the outside one we got 2y. Multiply it by the derivative of the inside, derivative of y is dy dx. And then you have the equal sign, the derivative of negative 2 is 0. So now we're finished doing derivatives all the way across. Now once you do that first step, then you want to solve for dy dx. So anything that has dy dx, you want to leave that on one side of the equation. Everything else you're going to move over to the other side of the equation. So I have x squared dy dx. I'm going to leave that alone. It has the term I'm looking for. Here's another part that has dy dx. So it's plus 2xy dy dx. Okay, so that takes care, these are the only two terms that have that in it. Everything else, these two guys, we're going to move them across the equal sign. When I do, they're going to become negative 2xy, and then negative y squared. Once you have all the dy dx's on one side of the equation, it's a common factor, you're going to factor out the dy dx. Okay, so you factor out dy dx, you're going to get x squared plus 2xy, you factor that out, equals negative 2xy minus y squared. The last thing you're going to do, divide both sides by what's inside the parentheses, and we'll be able to get our dy dx. So dy dx is negative 2xy minus y squared over x squared plus 2xy. You could leave your answer like that. Let's make this clear here. So y. Or what you can do is you can leave it that way, or you can do some factoring. If you were to factor, you could pull out a negative y there if you wanted to, since that's common in each of those. To get positive 2x plus 1, or plus y rather, you could do that. And on the bottom, you could pull out an x and get x plus 2y. So again, either answer is okay. The first one, or again this one, by factoring out the negative y, you could do that as well. This doesn't cancel because we don't have the same thing top and bottom, so that's the only reason why you'd want to try and factor it. Maybe you might be able to simplify that a little bit more, but in this case, nothing cancels. That's as far as you can go.